All right. Hi, everyone. Today, I'm going to be giving a quick walkthrough, kind of a really brief introduction to instrumental variables, right? Commonly referred to as IVs. And I'm really excited. I think this is probably my favorite lecture of the semester, right, in the Econ 300 lab. Um, I think it's a really beautiful idea because it's quite simple, very intuitive, and I think can really help us in applying the econometric toolbox to questions that we really care about. So, without further ado, what's the issue that we're really trying to overcome here? The issue is that of endogeneity, right? So we want to find the effect of X on Y, um, but we have this problem of endogeneity that we've been talking about the entire semester, right? And so this can commonly arise from two different sources, right? It could be that we have simultaneity where X affects Y, but it's also true that Y affects X. And the second one is one of omitted variable bias, right? So we want to understand the effect of X on Y, but there's something that we don't observe that is in the error term that affects both X and Y. And that's really shown here by what we call in the field a DAG. Um, so this omitted variable bias problem can really be summed up in one graph here. X affects Y, but we still see this U. Um, I will say there is kind of one more case, which is that of measurement error. Um, I'm not sure if you guys have gotten to it yet, but kind of essentially, measurement error can also lead to issues of endogeneity and can bias our coefficients. This is commonly known as attenuation bias, and so people also use instruments to overcome that. Uh, that's especially true in the economic history literature because you have a lot of this mismeasurement coming from newspapers and whatnot. But for right now, let's mainly focus on simultaneity and omitted variable bias. So, how do we solve this issue of endogeneity, right? We're going to use what we call an instrument, right? So, what is this instrument? Well, this instrument is going to be a variable z, right? Z is going to be highly correlated with x, and Z is going to be uncorrelated with Y. So for the purposes of this class, those are going to be really our two main constraints on Z, right? That's really all we care about for Z to be qualified as a good instrument, right? Highly correlated with our endogenous variable X, uncorrelated with our outcome. And the basic idea is really that we're only going to use the variation in X that comes from Z. So, you know, very simply put, maybe we get rid of all the bad stuff of X, all this endogeneity, and instead we make sure that what we're seeing in X is really only coming from some exogenous source. And so, how are we going to do this? It's really simple, right? Once you have an instrument, once you have that Z, it's very simple. And so, I just wanted to write down the three bullets because I think if you don't take anything else away, it's okay, right? If you can understand this for right now, I think that is more than enough. And it's very straightforward. We're gonna take X and we're gonna regress it on Z. We're then gonna grab those fitted values and we're gonna regress Y on those fitted values. And that's it. That's really all we're doing here. We're taking it, we're regressing our endogenous on the exogenous, grabbing the fitted values that come from the exogenous, regressing Y on those fitted values. That's all we're doing. And so for me personally, when I first saw the IV, I was like, oh, cool, very cool. Sounds interesting. But what does that actually mean in practice, right? What does that look like? So what I did here is I set up a quick little lesson that is going to be focused around probably one of the most influential papers um, in education economics, but it's also probably one of the most famous instrumental variable papers, which is going to be a paper from Josh Angrist and Alan Kruger that they published in 1991 in the QJE. And so the question that they're trying to study here is the effect of schooling on earnings, right? And so if you were to just run a regression of earnings on schooling, I think it's pretty easy for us to see where this could go wrong, right? I mean, the issue is that schooling is endogenous, right? Higher ability people, maybe more motivated people, are going to probably choose to do more schooling. Similarly, we may not observe some of the family characteristics or other unobservables that are almost surely going to affect schooling and earnings. And so Ingerson Kruger use an IV, and to instrument for years of schooling, they're going to use the quarter that somebody was born in. And so I want us to sit here and think about it for a minute. If your friend were to come to you and they tell you, all right, I want to run a regression where my dependent variable is earnings, and I want to see, the quarter that somebody was born in, how that affects their earnings. Well, we would probably say, what are you doing? I mean, it's not immediately obvious to us that the quarter that you're born in should affect your earnings, but that's only until you bring into fact that, all right, well, if the quarter you're born in affects your years of schooling, well, yeah, of course, then that makes sense that that would affect your earnings. And that's really the key for a good instrument, right? You want your instrument to be weird a lot of the time. You want it to sound funky. It shouldn't make sense to run a regression of Y on Z. Um, but that's what makes it kind of special, and in my opinion, pretty cool. So the background for the paper is that there were compulsory schooling laws in the U.S. School's only going to start once a year. The laws say that when you're 16, you can drop out, but until you're 16, you got to be in school. And we can take two kids, maybe say one of them was born in the fourth quarter and the other one was born in the first quarter. So maybe one was born in December, one was born in January. They both start school at slightly different ages, right? So, you can only start school if you're 6 by the time that the school year begins. So, somebody who is born in, on January 2nd, right, barely misses that cutoff. And somebody who was born in, December 31st uh, is going to be in the same class as somebody who's born in January 2nd. But however, note that when it comes to that year where they turn 16, one of them is going to turn 16 much earlier than the other one. And so, effectively, they're going to have the kind of the younger one is going to have much more schooling than the one that was born in January. Well, much more, probably a year more. Um, and so that's really the idea behind their instrument here. And we may wonder, okay, well, why is this a good IV? I mean, the quarter you're born in is highly correlated with your years of schooling for exactly the reasons we just said. And second, it goes back to the weird instrument issue where it's really hard to see why the quarter you're born in would affect your earnings until we see it through it kind of the quarter you're born in's impact being through schooling. Sorry. So that's really all we're talking about here. Z is highly correlated with X. Z is uncorrelated with Y. And so that's really all they do. And so what I'm now going to show you is, well, what does that look like, in practice to run? So I'm going to be operating under the assumption that we're going to run a two-stage least squares, which is probably the most common way to run an instrumental variable. So all we're going to do, remember, we're going to regress X on Z, grab those fitted values, and regress Y on those fitted values. So we're going to be running this in two stages, meaning we're going to have two regressions. Those are the two regressions, right? The first regression comes from running X on Z. In the paper, this is going to be your years of schooling on, the quarter you're born in. So, in practice, right, this will be three dummies. The reference will probably be the first quarter, but without loss of generality, right? This really holds, right? We're going to regress our endogenous variable on our instrument or instruments. We're then going to grab the fitted values from this, right? That's going to be our x hat. And then we're going to say, all right, well, this x hat Since it's only being predicted by z, right? This x hat is using only the variation in x that is driven by our instrument z. And so because of that, this x hat is going to be exogenous to our error term, right? To our error term for y. What are we going to do with these fitted values? We're going to regress y on the fitted values, right? So now what we're going to do is now we're going to run the regression that we really care about, right? We really want to know how does schooling affect earnings? Well, now we're going to regress our earnings, in their case, log earnings, on these fitted values from the first stage, right? The fitted values from the first stage are now here, right? In our second stage, we're running y on the fitted values. And so really the intuition is just that we're going to kind of throw away the quote unquote bad parts of X, right? The all of the endogeneity, right? The parts that are correlated with U. And instead we're going to keep the so-called good variation in X, you can think of it, that really comes from this exogenous variation, we like to call it. In our case, right, it's the variation in schooling that comes from the quarter you're born in, uh, and the compulsory schooling laws. And that's it. To reiterate, we're regressing X on Z, grabbing the fitted values and running Y on the fitted values. That's all we did here. And so to implement this in Stata is actually quite straightforward, right? So to do this in Stata, what we're going to do, right? Previously, we were regressing reg y x, and then reg y list of independent variables, right? Regress or dependent variable list of independent variables. Here, it's going to look very similar, and the code to implement this is really straightforward. This is all there is. So in this case, let y be our dependent variable. Let's let w1 through w3. Let's just call these our control variables, some exogenous variables, and let x be our endogenous variable, in this case, schooling. We're going to set x equal to our instrument, and really that's it. The code is just going to be, we're going to do an IV regression. We're going to run an instrumental variable regression, IV regress. We're going to use two-stage least squares. Remember, there's other ways to estimate an IV model, such as GMM, but for right now, we're just going to look at two-stage least squares. So we'll specify two-stage least squares. Dependent variable, independent variables in parentheses are endogenous, right? Independent variable equal to our instrument. And that's it. I mean, if you want, forget about the control variables for now. If we didn't have these W1 through W3s, it would be IV regress, two-stage least squares, Y, and then parentheses X is equal to Z. It's so straightforward. And yet, we have this really, yet it's such a simple solution to such a really big problem that we face uh, really every day, in which we want to estimate a model, but we suffer from this endogeneity, something that we've been talking about probably in the theory portion of the class for the entire semester. Well, this is one of the ways that we can overcome it. And so I hope this made sense. Just to reiterate one last time, we're going to have our endogenous variable x, our instrument z, and our dependent variable y. All we're doing is we're regressing x on z. We're going to grab the fitted values and regress y on those fitted values, because the fitted values are the variation in our endogenous variable that are driven by our instrument, which by definition is exogenous. And thus, it's exogenous to all of the factors that are in our error term. And that's it. That's the code. That's the idea. I hope this made sense. This is my first time giving this lecture, so if there's anything that I did not cover or went too quickly over, please let me know. Anything you think, would benefit future students, please let me know. Um, and yes, if there is anything that's still unclear, please send me an email. Please reach out to me. I'd love to talk about this. If there's, anything we cover in this class that I'd love to talk about, this is it. So, yes, I hope this was helpful, and I'll see you all tomorrow in class. Thanks.